Alright, so today we have a 15-inch retina that is not charging the battery and is not turning on. Needless to say, if you look on the microscope, it really does not take a schematic to get an idea why. Whoa. Alright, now for my current sensing video, you should by now understand that this right over here is the high side current sensing. So you have the charger coming in through here, and then you have the charger coming in again over here, but it's going to be coming in through a resistor. And what the whole point of this circuit is, as I've explained in the current sensing video, it's a way of seeing how much power the system is using. So it cannot measure current usage, so what it does is it measures voltage through a resistor as the voltage is actually being used. So I might as well open the schematic here so I can show you and you can have a clue what I'm talking about. I'm not going to go over this in detail because I already did it in a current sensing video. I've gone over this a lot of times by now. So I'm just going to go over the most basic elements here. So here we go. So we have the current sensing resistor over here. It's a 0.02 ohm resistor, and as I've explained many times, there is going to be a very small voltage drop across this resistor. This is where the charging power comes into the machine from the charger. There's a 10 ohm resistor going to the U7000, which controls these transistors that make 12 volts for the machine from the 16 volts of the charger. And there's another resistor going to here, and they're both coming from the top and the bottom of this resistor. The long story short, there's a voltage drop across this resistor. The voltage drop across that resistor is going to be dependent on the amount of power the system is using. The voltage at the top and the bottom of this is going to be dependent on how much actual current the system is using, and by measuring the difference between the top and the bottom of this resistor, this chip is going to be able to tell how much current the system is using and know if it's time to turn it off. And as can be seen in the microscope, something went terribly apeshit wrong. So you have this resistor, then you have that resistor. Both of those, needless to say, they've got to go. They've got to go. I don't need to take out the multimeter and measure anything. They're garbage. They are trash. So let's get another retina board for taking things off of. Aha! A board that has everything I need. Okay, so between these two boards, I should be able to have everything I need. So first things here is I don't know how this is going to come off. I don't have high hopes for this coming off without taking board traces off with it. I'll do my best to take this off without removing any board traces because obviously that's going to be a nightmare. I'm going to be using more heat than I usually do. I'm not going to be shy with the heat. I'm also going to cover it in a little bit of flux. A lot of flux. What the hell? It's destroyed and has a hole in it anyway. What harm can I possibly do? Okay. Then I don't care about overheating the chip because this chip is garbage. I'm using more heat than I usually do, and this thing is not remotely ready to move. Yeah, this is one of those situations where the thing is literally etched into the board. Whoa. Oh, dude. This whole side of it is just destroyed. See the nightmare on the screen? God. Hey, did it take off half the board? So that's... Yeah, it only took off a quarter. Where to even start with this thing? So you have a hole in the board over here. Usually that means you're screwed. Let's see if there's a short to ground anywhere over here. Because if there is a short to ground and it's going through the motherboard itself, at this point this can rest in pieces. Rest in pieces.